Hello, my name is Alexander Morari, and I'm the founder of ITKeyMedia. You've tuned into our ITKeyMedia podcast about Central and Eastern European startups that are in pre-Series A stage. And tonight, the guest is Andi Hektor, the co-founder of GScan. GScan is a 3D inspection scanners developer, applying natural particle flux and AI, a combo. Good afternoon, Andi.
Hi. Alex.
Sounds like a crazy mix of not only AI as a general kind of buzzword and so on, but also natural particle flux and AI, right? Why do you think this combination is now helping your potential clients? And then we'll switch into the verticals that you are trying to serve with your product, okay? So why particle flux and AI?
Yeah, you are very correct. It's a bit crazy, and that's definitely this deep tech. We are a deep tech company, and for example, I'm coming from the particle physics, and we have other wonderful people coming from the different fields. Some people also from AI, and that's the reason why we are combining these two technologies together. But maybe to give some background, why this technology is needed, I give some examples. For example, I believe that everyone has seen an X-ray machine at the airport. It's during the security check. It's typically what people are seeing is X-ray scanner scanning hand luggage. And probably also you remember, if you visit a doctor time to time, if you have some trouble with lungs or something like, or some broken bone, you have seen medical X-ray machine. So why we need X-ray is that it can really see through different things. So we are a bit kind of transparent for X-rays. But also probably you have seen at the airport and also in the medical during the medical check that X-rays, they are dangerous. So they can be used only for very short period. And so you need safety measures. You need protection of the operators. They need special training, and also behind all this wonderful technology, you have X-ray technology. You have huge amount of how to say bureaucratic things. You need special license and so on. But people, it's not very common knowledge that around us we have a lot of natural radiation. It's a bit similar like X-ray. It's penetrating us constantly. And the main part of this radiation is so-called cosmic radiation. It's coming from, to be very correct, it's coming from atmosphere. It's mostly muons, electrons, and positrons. But the source of these particles, this flux, is coming from space. They are cosmic, very energetic particles bombing atmosphere. And in principle, it's well known already. It's 70 years knowledge that it's in principle, in theoretical, it's possible to use this natural radiation as X-ray. But the trouble was that it was very expensive. 20 years ago, 30 years ago, there was even technology available, but it was so expensive that it was hopeless in the commercial use. It was just too expensive. But luckily, let's say 20 years ago, there was already first more serious research papers about that it's possible to use this so-called muon scattering tomography. I'm sorry, very long name, but there was some famous papers claiming that it's possible to use, and also detector technology was available for this. But as you know, from research, it was really kind of cutting edge research paper. It takes time, but surprisingly, in this field, the development of technology is very, very quick. First, what we need cheaper particle detectors, and luckily we have. Then the big trouble was the computational power, as it's very expensive. 20 years ago, you needed supercomputer to get image if you used natural radiation. Now we can use combination of more powerful computers, but also much clever algorithms. The machine learning, it's really kind of, I would say, revolution. What is going on during last decade? The machine learning was like baby 20 years ago. Now it's grown up, and it's every day technology. So combining all these components, it made possible to build this type of machine as muon or security scanner based on the natural particle flux.
Yeah, so let's park this for a little bit, and before we jump into the actually the first round of this conversation, this podcast about the solution itself, let me just maybe hang on the general kind of level. So you said that it's possible now, and this is what you are doing, to use cosmic ray muons, right? And cosmic ray muons for what? For penetrating and for actually understanding the content or understanding the shapes or the chemical, I understand also ingredients of inspected object, so to say, right?
Yeah, okay. That's right.
And,
yeah.
And cosmic ray muons is a type of natural, it's there in any case, right? It's a cosmic level, cosmic scale kind of radiation, right, with very high energy, but it's less dangerous, should I say, or more human friendly, right? This is the idea and the goal, than X-ray, right? In very simple terms, how would you describe this difference? If both are high energy, then how come cosmic ray muons are less or more human friendly than X-ray radiation?
I think the main reason, or I know that the main reason, is that the number of muons are just, it sounds a big number. Every second, every minute, 10,000 muons, they are penetrating 1 square meter of surface everywhere on the sea level. So it sounds like big number, 10,000 per minute. But if you think about the X-rays, then in the case of X-ray source, there are trillions or even more X-ray particles, energetic particles passing us. So that's make very big difference, and that's a reason why.
So less intensity means there's less mechanical damage at some point, right? Exactly, just because they do not disturb the atoms or molecules in a body, right? A human body, let's say, and so they do not leave this trace of damage, or burn, usually,
Yeah, it's the typically what is going to happen if you energetic particle is hitting you is there is damage of molecules.
Cool. Yeah. So now, if this is also high energy but less intensity, and you say it's enough for a relatively precise imaging.
That's correct. Right? Of course, the let's say quality of imaging is not so good as in the case of X-ray, and in the case of X-ray, we can tune this power very high, and also we can have a very big number of particles, and so we can very quickly do high quality, typically two-dimensional picture. But in the case of muon technology, it's built in this way that in the case of our technology, so-called muon scattering tomography, we automatically get out three-dimensional image. So it's one benefit of this technology, that you automatically have three-dimensional. And another big benefit is the, let's say, chemical information. To be very correct, it's atomic composition. What we can see. In the case of X-ray typically, what you measure is the absorption effect. It's absorbed by the material, and it depends just the density. So if you have, I don't know, let's say organic material, some plastic, or you have explosive material, and the density is same, then the picture is more or less exactly same. By eye, you can't say difference. They look exactly same in the machine. In the case of muons, we measure the scattering angle, and this scattering angle is very sensitive about what is the atomic composition of material. So using this extra information, this extra parameter, what we can, extra data, what we can get out, and using this data, we can say what is the atomic or chemical composition of the material. So, and this is the huge benefit in the real world, as for example, if you have an X-ray based security scanner, then you need human operator to say that, is this object, does it look like bomb? Is there some, you can probably you can recognize the explosive part of the bomb, but then you need some kind of mechanisms to trigger a bomb. So you need a lot of brain work to recognize this object. But in case of our system, as we can recognize the explosive material automatically, it makes, we can say that, okay, you have explosive thing in this luggage or whatever object, and we can trigger the warning automatically. As we already know that there is explosive material inside. So it makes this technology less, let's say, human intensive. And the big trouble in, for example, in this summer, if you remember, all the European airports, we had huge, long queues everywhere. And the main reason was that during the COVID, all the security operators, they left. And it was very difficult to get all these people back. And also you need certain training. You need at least 2-week training for new person to be operator, security operator, or even longer training. You need special X-ray certificates and so on. And it takes time and it's costly. So this is one big benefit. And maybe a third benefit of this muon technology is that muons are really, they are very penetrating. Even if you go to the underground, 100 meters underground, you can measure many muons around. In the case of X-ray, you need just let's say 10-20 centimeters of steel or liquid. The liquid is very untransparent material for X-rays, so the liquids, they absorb very, very quickly. So it's very easy to hide. If you have, I don't know, for example, sea container, and you put some steel, very heavy material, or even glass is also very, very difficult to penetrate for X-rays. And then it's very easy to hide. Or
okay. Yeah. Andi, one last thing here, I would say. In X-ray inspection technology, what you need is a X-ray emission machine.
Yep, that's correct.
An object somewhere in the middle, an object that you're trying to inspect, and a screen that reflects, right? That reflects the rays. Okay.
Yeah, or there is.
Is this
detector.
the same?
Yeah.
A detector. Is this the same approach with the muon flux technology that you are basing your product on, or there's a different one?
No, it's very similar in principle, but the only difference is that the source of the radiation is not. We don't have artificial source like in the case of X-ray, but our source is sky. It's more or less all the sky is radiating these muons.
Meaning you do not have to emit any rays or radiation. Okay.
Yeah, we don't emit anything. It's we are just using that kind of natural what is benefit of nature, and we just exploit natural radiation. But of course, as we don't know what is the exact direction of this, as these muons are coming more or less randomly, they are like raying. It's like raying down randomly from sky. We need upper layer of detector system to measure the, let's say, incoming particle very accurately. What is the trajectory of this particle? Then we have object in the middle, and behind object we have next the second detector measuring the outgoing particle. And what is going to happen is that this muon is coming, passing the upper detector. We measure this very accurately. Then it passes through the object. It's scatters inside slightly, and then we measure the outgoing particle. And then we can start to combine these small scattering angles. And if you have tens of thousands more particles, then we use so-called tomographic reconstruction, and we can get the 3-dimensional picture. And also we have chemical information about the chemical composition of the object.
Yeah, clear. Okay, now, so let's say enough of general introduction, both scientific and technical. Now, where do you stand with that, and how many different types of equipment you have produced or you plan to produce, and what do you think would be the most promising, even like size of the machine? Does the size matter in what you're doing?
Yeah, the first product will be a security scanner, minimal viable product, and it's the scanner size, or it's called the interrogation chamber. The size is around 1 cubic meter, so it's but it's a bit like tunnel-like system. So it's, for example, I just give kind of very rough image about the system. It's big. For example, we can fit a human inside. So it's a, and also if you have seen the machines at airports scanning hand luggage, they are more or less same size. Our machine is slightly bigger than these machines.
Okay.
But this is the security side, but also we have, as you know, in the case of new technology, it always can happen that you have new sector of clients. They see your solution and they start to think, oh, we need this technology. And we have a bit similar situation now that the construction industry if you do safety or safety assessment for bridges, big buildings, industrial big systems like, I don't know, for example, nuclear reactor is a very good example. You can't go inside the nuclear reactor, or you can't drill a big hole into the sensitive part of a big bridge, for example. But you would really like to know what is going inside in concrete or inside reactor. Is there cracks? Is there chemical changes and so on? And it seems to be at the moment there are no good technology in this market. And so we have seen that some clients, they are ready to pilot this technology also in this sector. So that's, I would say, this is kind of typical situation in the deep tech. If you have new technology, of course you are focusing to the first clients, but it can happen that some other clients they discover your technology and they feel very strong attraction that they need this technology. And then it's good. I would say it's somehow good situation that you can already, if market can measure that your technology is good, then it's very good sign that.
Yeah. Okay. So if I understand you are thinking about different business lines as well, verticals, and you focus on where you think is the minimal viable product might be most effective to penetrate the market and so on, and to get more traction. But then I understand what you have already had requests, right, or inquiries from other verticals. You mentioned buildings, bridges. In the situation of a building, would that mean that you need to have, imagine there's a wall and you would need to have one part of the machine here and other part here, and then go or move smoothly, right, along the wall? Would this be the idea? And that means technically two people are holding part of the scanner?
Yeah, exactly. Or it's cheaper to fix these plates using some, I don't know, robotic system or just kind of simple mechanical system to fix them. But also it's possible, it's interesting that in this case, we can use only one plate in one side, as we don't need always both side plates. And the reason is that we have more time. It also needs a bit more time, but typically in this sector, the time is it's not so critical.
So Andy, interesting. I thought the prerequisite was to have two plates that they emit, like the emitter or measurement on one side and measurement on the other side. And now you say one is enough. How come? Can you explain this in simple terms?
Yeah, I try. In principle, if you have two plates situation, we have one plate above the object and one plate more or less below the object. And then we measure incoming particle and outgoing particle. And we can measure the tiny scattering, the change of the trajectory. In the case of a one-sided experiment, we are measuring shadow of the radiation. It's a bit similar like typical radiology image about, for example, if you visit doctor, you have seen all these lung pictures. If you have, I don't know, I hope you don't have, but tuberculosis, for example, they do a radiographic picture, and it's a bit similar, but it takes much more time. And in this measurement, you don't have so much information about the atomic composition. You have some, but it's much more. It's a bit more like X-ray imaging. if we have two-sided experiment, then we have much more information about the chemical composition of the object we are measuring.
So on your website, you also mentioned here that you have you haven't planned small, medium, large size, right? So you mentioned already that the MVP would be the smaller size, which is logical. But then having this in mind, but also that you have to combine the deep tech challenges with software challenges, with hardware challenges to produce it actually somewhere down the road. What's the main, let's say, business model you would say is to focus on the deep technology benefits, or let's say differentiators, or the hardware itself, or I mean, what the company will be like in the future? Still deep tech, or deep tech and hardware, or you will be selling licenses for producing the hardware in the long run? How the company will change, you think?
Yeah, I think as in the normal case, I would say we should more focus on the client side, and probably the service model is better, as it give. Then we have more data we are gathering more data from clients, and we can use this data to build a new model, new business models, maybe even business verticals. And it's kind of normal nowadays that if you're a hardware producer, you don't produce all the components, you're licensing out some production. But of course, it can happen if you have, let's say, basic production technology already somehow fixed or stable enough. Then we can start to negotiate with the component producers to really licensing out producing some components. So I would say in the current phase, it's too early. We need some experiences, but in the end of just a bit assuming here, but in the end of next year, we are really start to negotiate with the component producers, and also maybe some other schemes how to do this. And we really try to focus in the client side, software, data gathering,
interpretation,
and also, of course, building new products. And also, as I mentioned earlier, the machine learning and AI is very important thing. So, as you know, to build very good machine learned models, we need a lot of data and high quality data. So it's better to focus in this side where we can collect data, and the data gathering is some a bit under our control.
Amazing. I mean, for me, as an outsider, I think this is amazing. For you, probably this is a daily pain in the neck. All the challenges that you created a company where the challenges are piling upon each other from different layers, like deep tech, like, deep kind of understanding of the physics and atomic physics and so on, but also hardware, and also how to properly create the interface between the data and then the outcoming results of this data analysis, and then actionable insights. Hell of a challenge you created for yourself. But I understand this would also probably, create some kind of a barrier of entry. Would you agree that there's a barrier of entry?
Yeah, a bit. And of course, what is I think very important part of the let's say very relevant knowledge is how to build this type of very complex new technologies. Is that you have to be able to collect good people who already know certain components of this technology. So you don't have to build everything from scratch, but you can find a good person, or let's say talented person for that. Also, you need ability to collect information from the research literature, from other sources. You need very good network to, as I would say, the most up-to-date information is available directly from people, as there is always lag between the published papers, published materials, they are always a bit old. So you need really good contacts in this field.
Yeah,
and also in the case of our company, I would say that deep tech part this is the big issue in the beginning, but now the big deep tech is already a bit behind us, and what we are doing now is really putting together. It's engineering more. I would say at the moment 95% of work is engineering. It's not deep tech anymore, but of course you have to be successful company in long term. You need kind of innovation cycle inside the company, that you have to keep this 5% deep tech at your company. Otherwise you lose if you have competitors having a very good research teams, then you start to lose at the end of the day.
Oh, wow. Interesting. In future, not currently, but in the future, what would you say would be the 2 or 3 key mainstreams of revenue for the company?
I believe that it's a bit how to say, gut feeling. It's difficult to say, but I feel that the first clients paying pilots, they are coming not from the security sector, but that they are coming from the construction and the industry sector.
Oh, interesting.
Yeah, I can really feel the kind of need in this sector, that they are really eagerly looking for this technology, as they don't have other technology available at the moment. Or it's possible to use the X-rays, but it's so expensive and it's so complicated. The machines are so big that it's in reality I know only a few cases they are using high energetic X-ray in construction sites. But in the case of our technology, it's much more flexible and it's safe for people and so on. Security, in the security sector, I believe that in long term, it's very, very, the market size is huge in this sector. Also a bit, let's say, Europe is in general a very safe place, but it's this technology has more attraction in the regions we don't have so much security. So it takes time, and also of course the client sector is different in construction industry. In the case of industrial clients, all these are business clients, so it's B2B business, and it's always much quicker. In the security sector, our first clients, we believe that they are public sector clients, and as you know, public sector is it's a very, very slow sector, in the sense that you have to plan everything 1-2 years. But if you in one side, it's very, very slow. But if you have already momentum, then it's good place to be. It's very safe. You have very long-term contracts. It's even if you have economical crisis, you are kind of safe. B2B sector is much more fluctuating. So there are
easier to land a contract with private sector, but then just to say in public it's much more difficult to get into it, but once you're there, it's a pretty sticky type of client, should I say, right?
yeah. And of course, what we like to do also in this custom and the public sector is we would like to a bit shift the market more towards service type of contracts. Not to sell the hardware, but keep this as a service. Of course. I mean, if all goes well and successful according to your plan, this would be more, profitable for the company, right? But at the same time, you are in close connection with the clients and can react quickly to their needs, requirements, and so on and so on. Would that one last question here in this round? Okay, would that also imply that you plan to keep all the data analysis, interpretation, so on and so on your platform, like Matterport is doing the same? They do 3D scans of 3D viewings of properties, right? But you cannot export. You have to maintain your portfolio on their platform. Do you plan to have the same? Yeah, as much as possible, I would say, in this way.
Cool.
In the case of public clients, they have certain needs. There are, let's say, some legacy we have to consider, but we try to do this in this way that all the data is coming to our servers, and then we we can generate extra, let's say, value using this data.
Yeah, but also to keep this data, I understand you will take some monthly subscription, right? As well.
Yeah, of course, this model
then
is...
I'm okay. Then I'm not worried about the company at all. If this is the plan, I think this is a good way, and this will definitely help you to maintain one stable stream of revenue there, of course. Of course, this goes in connection with happy clients, effective implementation, but also the providing and delivering all the benefits that you promise, and so on and so on. Interesting. Andy, thank you very much. I think we've managed to show clearly the potential of the technology, of the hardware, of the usage in different verticals, the differences between public and private sectors. And wish you good luck with the implementation that in reality. Let's move on to the next round. Round two, the competitors. I understand that you have like huge army of competitors that are using X-ray technology, X-ray tech. What about the ones that are using also the ART or the atmospheric ray tomography, the muon-based scanning technologies? Are there many of this type, and how far ahead of your company they are, you would say?
Yeah, it's this market is not ready yet, of course, and so there are not so many competitors. So let's say I can say approximately 10 competitors. Of course, there are many potential research groups. They can easily have spin-offs if they are, I would say, if they have active business active people around. But yeah, it depends. But also these competitors, they have a bit different corners they are working in. For example, there is one security oriented startup in US. It's called Decision Sciences, and they are using gas detectors. They can build only very big systems using gas detectors as the detector panels. They are like approximately 1 meter thick, so you can't build a small system, but they can build the big ones, and they have sold maybe 4-5 systems, maybe even more, but we don't know all, of course. And yeah, they are developing, but I would say there are some limitation in the case of their technology. And then there are another corner. It's a geology and mining industry, as what they are looking for is to understand what is underground. And of course, the muons, they are really penetrating. So it's possible to use muons to discover something new underground. So there is in Canada, there is a company Ideon Technologies. They are developing very special type of detectors. So you can drill the borehole, and so you need very small system. It's very specific. It has to tolerate everything, what is dust, humidity, water, whatever. So it's a very special type of system. But they already have first pilot commercial pilot project running. They are looking for, if I remember correctly, uranium in Canada. There is a lot of mining industry. And so it's really, I would say, interesting project. Then there are some companies also in UK. And what the starting point for these companies was in nuclear industry. As what is trouble in nuclear industry is that you can't be very close to the nuclear reactor, and if you have nuclear waste, it's very radioactive. They put this to the special storage element, and you can't open this. The question is how you can check this. This is very heavy material around, and it's impossible to use X-ray, and it's not penetratable for X-rays enough, and so they decided to use muons and cosmic rays to scan this. But again, it's a, how to say, specific, very specific market, very specific solution. So they somehow optimized. But definitely it's more about, I would say, it's all these companies, if there are very strong wish to go to the new market and the money behind, then they are able to do magic.
Interesting. So your entry point into the market is different from theirs, right? So you are now using similar technologies, but in completely different kind of areas. Okay. Interesting.
And also, I would say, what is the big difference that we picked up? Very tough question: how to solve, how to build the security scanner. As all the other companies, the initial idea was to build to discover something, let's say something heavy and more dense. So the US company, Decision Sciences, they started from one public grant from the government to find the nuclear materials, and they are heavy metals. So it's kind of, so I would say they optimized the technology for this special question asked by the government. But in our case, the initial question or the story starts with another project. The question was how to count people in a vehicle. There was passenger car. There was the Estonian government has idea, or maybe it was even European Union project to build the fully automated border gate for cars, the passenger cars.
Yeah, okay.
And the question was how to count people inside. And of course, you can't use X-rays. It's too dangerous. And we got the idea, why not use muon technology? It looked too expensive in the beginning, and also but what was the nice side of the the idea that the people we are made by very light elements, so water mostly. So we are very, how to say, not very dense objects. And as we optimized our first exercise for that, then I would say we developed very good technology to find really difficult objects, and we succeeded to so far.
Andy, it just struck my mind. I think we've been focusing on the quality of the scanned objects, like the chemical composition, explosive, non-explosive, and so on, or whether or not this is, I don't know, it's 3D image shows a pistol or any other arm or gun or whatever. But you just hinted at this, and let's just maybe stop it on this a little bit. I understand the system might also make it easier to count the number of objects in a container. Would that be true?
Yeah, it's in some sense, yes. For example, if as you know, for example, if you have a sea container and you are exporting or importing something, then you have a so-called good declaration. Describing what is the inside, and of course it's, how to say, if there is some criminals, they would like to cheat, for example. As you know, taxes can be very different for different goods, and the big question at customs is that what is inside? Is the goods declaration correct or not? And for example, our technology can check this. For example, if you say you have a sea container is full of bananas, so using our technology, you can really even automatically you can say that, okay, this is banana-like material, probably these are bananas. If you have something else, you have steel or cocaine or something like that, and you automatically recognize this. Okay, this is not what it should be.
Or even, for example, I'm buying from my supplier, I don't know, building materials, let's say, and these building materials are, I don't know, even like bricks. Let's take a very primitive example, right? Even a brick. So there's a truck with bricks, and you are selling these bricks to me, and you say we have like 3 cubic meters or whatever, and then somewhere down the road, would I be able to run this truck through a tunnel with your models and so on, and know exact number of goods that I'm buying? Let's say bricks in this case. Would this be possible?
It should be possible. Of course, there are certain limitations. So if the, let's say in the case of bricks, they are very close. Let's say there are no empty space between these. It makes more difficult probably. But if you have some, or for example, I can just give one example. One producer of car batteries. As you know, the electric car, you have huge battery. The weight of the battery is, I don't know, 100 kilograms, and they are big. And they ask about, is it possible to do kind of quality checks for these batteries? At the moment we said it's too, how to say, it's too specific question. We don't like to focus on this very specific. It takes a lot of time to really understand is it possible or not. But I think in long term there are many possible use cases also in industry, and also, for example, mining industry. As if you have big mining, you have the material coming out from a mine. Then you have to kind of quality check. Is it what is the content of this material? And at the moment, they try to use X-ray, but X-ray is not penetrating enough typically these materials. And this is one example of our technologies. As we are more sensitive, what is the chemical composition of this? Probably we can get the better answer there. And
more precise, quicker, with time, cheaper, safer, and so on. Interesting.
And of course, it's always people asking, is there any medical use for this? And I can say long term, yes. As we have one interesting project together with the Exeter University in UK about the bone tomography. But I would say medical and health applications, they are very long term. It's so at the moment we say that we have a collaboration. It's R&D. The university can do all the. we can just provide the technology. As we don't have manpower and the energy to really work for many products. We're really focusing at the moment to get the first product out. After that, we can start to think about much wider. But at the moment, we're really focusing to push the first MVP out from door and to start to pilot this with our first client.
Yeah. I mean, this sounds like a whole new business altogether. 3D imaging of bones, right? And for medical uses. Interesting. Yeah. Andy, we could go on forever because there are so many unexpected, probably verticals and directions how to utilize, or to at least to brainstorm the usages of this technology and this solution. Let's move on, Andi, now with round 3. That's a very quick Q&A, and most important for me is to hear how you, as a definitely busy founder of a company, managing to achieve a lot, and what are your productivity hacks? Again, not the tools, but the productivity hacks that keep you productive and help you be productive and on top of things. Could you share with us anything?
Yeah, sure. It's always very difficult, but I would say I'm a bit lucky person in this sense that I'm coming from the research and the academic world, and it's especially the cutting edge research. It's also very competitive. It's intensive. You have to talk with many people and you have to share ideas. So I would say it's a bit similar in some sense, but also it's in some sense it's very different. It's difficult to explain even that there are some elements they are very similar, like competition and these elements, but also academic world is somehow you are a bit alone in this academic world, as typically you have to do many things alone. In startup world, it's truly opposite, as you have to do everything together with a team. If you don't have a team, then I would say you have no startup, and you have to learn very quickly how to organize things very, very, very quickly. So it was in the case of my background, it was a bit difficult in the beginning, as it was difficult to, for example, delegate the task. As in academic world, you have to do more or less everything yourself. But I have learned this, and also what is very important, and I already know this before from academic world, that if the work is very intensive, then you have to find in certain moment you have to stop. You have to say that, okay, I can't work every minute. I can't take calls. For example, if I have partners around the world, it can happen that from US or from Japan they are calling in the wrong time. I can't. I should switch off the phone, and in certain moment I have to say that, okay, now it's quiet period. Especially if you have family, of course, then it makes very, very difficult. And also it's very,
to be able to say no, at times.
Yeah, you have to feel, and then even I would say, as of course, time to time you can't say no. If you, for example, we had very intensive deadline yesterday. We wrote a big project. There was deadline. It was crazy during last days. I was sleeping maybe 3 hours per day. But you have to say that, okay, now it's finished. Now I have to take let's say 10 or 1 day break, very certain break, and I have to go away, and I have to relax and to be together with my family and my kids and so on. And this is very important thing. If you have family, then you really have to define that you have to spend a certain time together with your family, and it's difficult in the startup world, as you have to travel a lot and so on, but you have to somehow define this. And also in my case, I try to do some sport. I try to move, even if it's very, for example, if it's a very busy period at the office, I try to take, I don't know, 15 minutes, take a small walk around. It's also mentally very relaxing, and then come back, and then I can continue like a bit like fresh person.
Yeah,
and so these are my hacks.
Yeah. As a side note, you mentioned, I think, something that is interesting, that the work in a startup is pretty similar, you mentioned, as scientific research activity, right? And I think this is pretty much true, basically, because in scientific methods include what? You have a question in your mind, right? Then you, I don't know, gather or perform research, you gather data, you then establish a hypothesis, make observations, analyze, you do some action if this is like a physical world kind of research, then you analyze the feedback, draw conclusions. If needed, repeat the process to reiterate that. And that's very, very similar to startup. You know what? Have you maybe noticed that there's not much literature, I would say, on the comparison or on explaining how a startup is similar to scientific research, and not many founders are aware of that. Some of them are doing this by naturally, kind of. Some of them come to the scientific methods used in startups because of their practice, but it's not widely popular to compare a startup activity with scientific research kind of activities. And it's a pity, I think, because lots of mistakes would be easier to avoid. Would you agree with that? That we need to spend a little bit more time on approximating or explaining first scientific methods and then bridging these to startup growth and development.
Yeah. As you said, Alex, it's very true in the sense that the methodology, how startup should work, should be very similar to the researchers. So it's a cyclic. You have hypotheses, you have to test these, and if they are not correct, you have to pick up new one, and you have to do this very quickly. And this is the similarity, but there is also a big difference in the sense that in academic world, people would like to be really deep, as they would like to dig out everything. In startup world, you can't. You have to say that, okay, now I have to stop. I have to move away from this. It's not working. It's a bit like engineering. It's more like engineering in this sense. And also, the big difference in the case of startup is that in scientific world you can somehow, if you can't solve let's say in the end of the day you can't solve one problem, you can pick up the next one. You can say, okay, I can't do this, let's pick up the next one. But in the case of startup or engineering, you can't say, if you have to build your business line, it's end goal. You can't say that, okay, I'm doing totally different. So
yeah,
you have.
It's not that easy to jump from topic to topic, right? You want to say?
Yeah. You have to be really focused and but also flexible, as there are no clear path in the end of the. For example, it would be very nice to have kind of make table and a very clear project. Okay, in this day we have MVP, then we have a final product. But in reality, there are so many obstacles that you have to be really flexible to. But you have to, you have to move forward. But it's a bit like snake going around and finding a better way.
Good. Andi, thank you. Let's move on to round 4, the company. So you said the company was founded in 2018, more or less, right? And there's a whole team of founders. If you could mention the founders, founder team, because I understand all of them are pretty much experienced in business or in science.
Yeah, we have 4 main founders, but of course many people are around. It's as deep tech and hardware company, you have always more than one person around. But we have 4 main founders. One is Hannes Plinte. He has background in IT and business side. Then we had Mert Mägi. He is very good technology person. He's coming from the defense sector. He built many defense systems in Estonia. Very experienced. Then we had in the initial team we had Madis Kiisk. He also has academic background and PhD, and so we are somehow we have some special feeling about that. We are coming from academic side, and he was working in nuclear and radiation detection field. And I was working in particle physics and detector physics and astrophysics. So I'm coming also from academic side. It was the initial team. Of course, other people also around. And also what is maybe a bit different from the typical startup, at least in Estonia, typically startup people are very young, like below the 40. We have all the team. Initial team was 40 plus, so it's a bit different from the typical startup young boys around.
Hey, interesting. And tell me, Andi, what do you think are the advantages of being 40 plus, 50 plus founder?
I would say the one big difference is that, of course, if you have family, if you have kids, and you are 40 plus person, then to make decision to be founder at startup, you have to really you have to think deeply, and you have to discuss your family, and so you have to be very sure that it's. So I would say it's kind of like due diligence process, and it's very careful due diligence, as of course you have to discuss your family and
did you discuss yourself with your family? Was switching from scientific work to startup?
I had very how to say it, as I would say it's a in some sense the academic world is a bit like isolated, so they don't know so much what is going behind the academic bubble, and you have kind of academic career building is kind of long.
Yes.
You have very big. You need the target, and you have to build this, so it's long process, and it's a bit like military world in some sense. You have certain rules, and if you're coming out this, you in the beginning you feel that you have no floor in some sense.
Yes.
It's very difficult to somehow. But on the other hand, I'm really happy about this decision, as when I was in academic world, I was always missing about the communication. I'm a very communicative person. I like to communicate. I like to discuss about ideas. I like team building. I was missing about that in academic world. And another big thing is that in academic world, you can do many things as abstract things. So you never see these things in real life. You don't know, is it this theory or science you're doing, is it valid? Maybe after the 20, 30 years, nobody knows this. But if you do,
it's proven wrong, or it's proven wrong,
it
or
can
something.
Be proven wrong. Exactly. It's very common, as I would say in academic world, 99+% of things, they are just ideas, and you need time to prove this. But in the case of the startups and business, you can really choose something ready, and it is practical. In the end of the day, you are helping people, you are helping community, society. So it's I would say this side is I was really missing about this in academic world. And you never see kind of very clear results in everyday life.
Oh yeah, clear. Wow, interesting. So you mentioned a couple of, you were a founding team, and as far as the whole team, how many people you are right now?
At the moment, we have more than 30 people around. But as I said, we started as let's say 4 core people, and then some people also around.
How difficult it is to get into your team?
It's not easy, as we need people having kind of specific, at the moment, we need people having very specific knowledge, for example, technical team. So there are not so many people around, but also we are open-minded. As to be honest, Estonia, for example, Estonia is a small country. It's many very good engineers in our case. They don't have background in particle physics or this type of electronics, but if we can see that this person can learn quickly, is open-minded and able to work in this type of intensive, talkative, communication-rich environment, it's also important. As some people are very good in engineering or research, but they can't work at startup. As they need more stable environment. They don't like so much communicate. But in startup, you have to so
I think it's more or less clear, like what kind of people and highbrow IQs and so on you need for the technical side, for the scientific, the hardware and software and so on. What about the frontline guys? Are you now ready to hire, or do you have maybe somebody on the crossroads of marketing and sales and kind of business development, or is it all founder-driven business development right now?
Yeah, in October, from October we have new CEO, and he's coming from. He has interesting background as he started as Marek Helm, his name. He started in public sector. He was very innovative guy. He introduced many new things in public sector. He was the head of the tax office. He introduced all these wonderful IT things in Estonia you can see in public sector. And then he moved to the business. He was heading the one branch of the IT company in Gulf region, and he was very successful there. He built a big revenue there in this region, and as you know, this Gulf region is very difficult business culture. So it's it's very special. So I would say he's very flexible and able to really build. Business lines, client base, and also the marketing, good marketing team.
So cosmopolitan experience, and even in like most difficult markets to enter and so on. Cool, interesting. And so, as far as sales and business development and kind of promotional activities, Marek is doing this alone right now.
Yeah, we hired the first person for communications, so we can cover PR part. Also, we have very good partners. We are using, for example, one PR company, media company, and I would say in a startup, it's very expensive to hire people. So we decided that. We are using many partner companies and also we have some teaming agreements. For example, in Singapore, we have a very wonderful teaming agreement with one wonderful tech company They are integrator of the iPort technology, IT, all kind of this technology. So I think as a small company, it's very expensive to build the big sales team and big marketing team in the very beginning. But you have to be ready. Also, what we are doing now, we are building kind of readiness to after the next round. We have to be ready to hire, be bigger. At the moment, we have our sales team is two persons. We have sales director. It's also he's a very interesting guy coming from Australia. He has background in customs and he's really wonderful. He has been everywhere. There are no place around the world. He is never.
You mean Jeffrey? Jeffrey, right?
Yeah. Jeff is very great guy. As he was working as initially as custom officer, but then he was training different customs around the world. So he has been
okay, cool.
All the world.
How did you find him? How did you find him? He approached you, or you somebody recommended?
Yeah, exactly. This is kind of a nice story. As he was working at our competitor in the US at Design Sciences, and then we had first the big project financed by the European Union. We got the
big grant.
Yeah, big grant to build the prototype system for the sea containers and trucks, big cars. And then he somehow heard somewhere about that, and then he decided that okay, it's a so nice project and it's a nice company, and cool. let's join. And then we had some discussions, and then he decided to join.
So amazing. Okay, so you attracted him by yourself, basically, by the sheer idea of the company.
Yeah, to be honest, it was 1 year ago, and we had no, how to say, it was too big bird to shoot. We thought, but luckily it was.
Yes. Andy, one thing off topic a little bit right now. Would it be easier to retrofit an airport or approach an airport which is planned to be developed or built?
I think it's a similar. But of course, if they're building something very new, then they are more open about the innovation, especially if they are early development phase,
design stage, concept and so on. Interesting.
And also they know that it takes time to build a big airport. The design phase is long. It takes, I don't know, 10 even more years, and they have time to think about new technology, and they are open-minded. So I would say that we are already discussing with some project that they are thinking about our solution. But of course, on the other hand, the airports are very regulated by the international rules. So we can't introduce our technology immediately, as there are very certain also very expensive certification process and so on. But we can use our technology as extra security measure. And if you have been in Europe, we don't have, as in Europe, everything is very safe. But if you go to some other region, then it's very common that before this aviation check, you have I don't know, screening.
Yeah, clear. I mean, so here's a layer which is highly regulated, and you can offer or provide additional layer beyond the regulated kind of areas. Interesting. Let's move on now. The last round 5, Formula F3, as we call this, which is funding the future. So in a couple of words, sentences, where you stand right now as far as investment, and what's the plan for the next phase of the company development?
Yeah, about the financing and the investments. We have been kind of successful attracting the public grants. So that was one reason why our first seed round was a bit, I would say, later than the usual startups. And also, as we are hardware and deep tech startup, the development is not so quick as in the case of, for example, software. It takes a bit more time. So we finished our seed round or pre-seed round, if you like, in this spring in May, and we collected 2 million euros in total. And now we are preparing for the next round. As we have MEP getting ready in probably in May, February, and then it's a very good time to and also our first client, they are coming, so it's time to open next round. We don't have at the moment, I can say very clear conditions, but I can say that we try to collect something like 5 up to 10 million euros. It also depending strongly what is the grant flow, as we are continuously applying new grants, and so the investment need depends how successful we are, as we are waiting also some results. So, but yeah, in January I can say what is the round we are expecting, and as we should build the next, we should extend our production. It also depends what is the pathway to build the next production sites. As there are different ways to how to expand, and probably in the security field, we can really see that the pathway is to build to have distributed system, that we don't have one big production site, as there are many. For example, US Gulf region countries, they are protecting security technology is something. How to say, they would like to. It should be produced close by.
Oh yeah, okay.
Definitely in US, in Gulf region, we should open the separate production site, and it's reasonable to do this together with the local partner, so has joint venture. So this is probably the way. But of course, we keep the core IP, we keep the core software development, we keep some let's say components of the production technology, and but this is one way to how to build international, how to scale up internationally, as to collect a lot of investment and start to do everything alone. It takes much more time. So it's better to have kind of very good partners around the world, and to build local production sites all around the world.
So it seems like not only R&D heavy, not only IQ intensive, or should I say, company, but also capital intensive. And with the plans that you just shared, I think it just takes time. You have all the other ingredients to reach your next milestones that you plan for your company. And I wish you all the best. And let the muon flux, let the muon flow be unstopped and uninterrupted, and flowing forever for the success of your company. Andy, thanks a lot. That was great and very instructive. And I think I've made a very huge jumped a very huge learning curve for sure. All the best. Good luck.
Okay, thank you. Thank you for having me.